Okay, in this presentation we're going to look at sequences in series. So there's two parts of this question, parts A and part B, part A and part B. So the part A is broken up into two parts. Find the 50th term in the arithmetic sequence 150, 143, 136, 129, and so on. And the second part is how many terms are positive. So clearly what we can do straight away is just looking at this sequence is that we can tell that the first term there is 150 and that the sequential difference, which is the difference from one term to the next, is minus 7. It decreases by 7 each time. So there we can say that A is equal to 150 and N is equal to, D is equal to minus 7. Now the question is, what is the 50th term? What is Tn? Okay, what is the 50th term? Okay, so we use this expression here. This is the formula that we would use. So the nth term, Tn, is equal to A plus n minus 1 times D. This is really straightforward enough. This is using the calculation there, the calculator. So we have 150 plus n minus 1 is 49 and D is minus 7. So we multiply 49 by minus 7 and we will get 343 there, or minus 343, okay? And therefore our answer will work out to be minus 193. So that's the answer to part 1 of part A, okay? Now the second question is a little bit tougher. So what we're asked to do is find out how many of these are positive. How many of these terms are positive? So essentially what we need is a condition of n, okay, such that t of n is greater than 0, essentially. Okay, it could equal to 0, but essentially n is an integer, so okay. So this is how we start out. So Tn must be positive, okay? So we have to find some value of n for which this is true, okay? So essentially what we're going to do is rewrite T of n as A plus n minus 1 times D, and that is greater than 0, pardon me. So just using our terms, A there is 150, n minus 1, we don't know what n is, so we'll leave that as n minus 1, and D here is minus 7, okay? And that's using it all. So essentially what we're going to do here now is we're going to just simplify the whole thing, or start to calculate it, or simplify the expression, or algebraically work it through. 150 minus 7n plus 7. Just watch out for the minus signs there. That minus sign gives us those results in that minus and that plus there. Okay, so we're just working it out. 150 plus 7 gives us 157 and minus 7n. Okay, so 7n minus 157 is less than 0. Just actually what happens here is what we're doing is we're changing the sign, okay? So from here, it's greater than 0, but what we're going to do here now is change the sign. We'll just sort of write everything in terms of n. So 7n rather than minus 7n. So essentially we're just switching the sign, which means that we have to change that term there. We have to update that term there, that directional operator, appropriately, okay? So 7n is less than 157, okay? Just adding 157 to both sides. So therefore, n is less than 22.4. So essentially what we can say is that the first 22 terms are positive, okay? And recalling that n must be an integer. So that's part A, okay? Now, the second part here is as follows. Find the sum of the series 11 plus 13 plus 15 all the way up to 51, okay? So this series here, it's an arithmetic series, 11, 13. The difference there is 2, with the first term being 11, okay? So essentially what we have to do there is find out how many terms there are. So the nth term there is 51. So essentially what we have to do here is work it out what n would be if the nth term is 51. So we have 11, A is 11, plus n minus 1 times 2 is equal to 51. So that means that n minus 1, 2n minus 2 is equal to, subtract 11 from both sides. So you can sort of see that quite clearly that n must equal to 21, that there's 21 terms. It's the 21st term essentially. So n is equal to 21. Okay, so that's important. We're going to need that now. Okay, so the next thing is there are 21 terms, and so essentially what we're asked to do is calculate the sum of the first 21 terms. So we're going to use this calculation here, this definition here. Okay, so that's another one you have to know off by heart. That one there is one you have to know off by heart, and this one here is one you also have to know off by heart. So using our values, n is equal to 21, so 21 over 2. Okay, 2a, that's 2 times 11 is 22. n minus 1 is 20, and d is equal to 2. Calculate it all out, we get 10.5, which is 21 over 2, times 62. 22 plus 20 times 2 is 40, so 22 plus 40 gives us 62. Bit of calculator work, and that gives us an answer of 651. So we'll leave it there.